If you're like me, you probably noticed that 3D modeling software are moving gradually but certainly towards proceduralism. But first of all, what is it, and why is it such a big thing now? For example, with every Blender update, we can notice a certain shift in focus towards proceduralism, making it a perfect demonstration of how the 3D industry have been moving towards procedural tools in recent years. But how about parametric modeling? A less popular yet equally fascinating approach. While it may not be at the forefront of productions compared to its counterpart, it still made its name as one of the most interesting ways to do 3D modeling. So what are these modeling techniques exactly, and how do they differ from each other? Here's the deal. Both parametric and procedural modeling share the core idea of automatically generating 3D models and reducing the labor required to create 3D assets. However, they differ in their techniques and strength. So first, let's start with their definitions. For parametric modeling, the term can be quite confusing since it overlaps with other 3D concepts, but don't worry about that. Simply, it is a semi-automatic way to create and edit 3D models without doing everything manually. And here is how it works. For example, in 3D software such as Blender and Max, we have amazing tools called modifiers. These tools allow you to perform fast modeling operations without the need to do everything manually, like bending stuff, creating spirals, stairs, smoothing operations, Boolean operations, and so on. So you can do all of this and control the process using a set of parameters, hence the name parametric modeling. On a side note, this form of modeling is very old actually, because it dates back to the early 90s. Procedural modeling, on the other hand, is also a technique that automates the creation of 3D models by using what is known as nodes and combining them to create what we call a node tree. So, these nodes are boxes filled with settings to determine the layout and shape of your model, but also for further editing, such as, let's say, a bevel node to make the edges of your model look smoother, or a node to add cuts to your model, and another one for curving or deforming it. Now, it might sound almost identical to parametric modeling in the spirit, because first of all, both are non-destructive, meaning the details and editing can be adjusted at any given moment by sliding the numbers, which can be done with the manual method. For example, if you're modeling a building and you have already designed a bunch of windows, you can't just use magical buttons to change their size or shape, but you have to do it again from zero. Or at least you have to manually adjust polygons and vertices. Meaning both procedural and parametric modeling eliminate the work that is needed to be done by manual modeling. But they are not necessarily similar for reasons that we will discuss next. So the first distinction lies in the foundation they are built upon. Procedural modeling often relies on polygons, and these 3D models are widely used in game engines and VFX 3D software. On the other hand, parametric modeling is predominantly used in CAD software. And speaking of that, being commonly utilized in CAD software, it is not a surprise that parametric modeling excels in generating designs, products, and buildings. The fact that it relies on a precise set of predefined or custom parameters means that it has an advantage of offering a high level of control over individual elements, and you can pretty much pick any line or any detail of your design and right away adjust it. While that can be a bit trickier with the procedural counterpart, with this parametric style of work, you can change the length, width, height, and the design shape, and many details. This level of control is particularly beneficial when creating designs that require specific measurements, such as in engineering. But on the other hand, parametric modeling is generally worse with organic shapes, and it doesn't offer the level of freedom procedural modeling offers. And this is for a plethora of reasons. But before we do that, let me tell you about today's video sponsor, ShapeLab. ShapeLab offers many features and advantages for creating high-quality 3D models in VR. It is fast, reliable, intuitive, and most importantly, it has a powerful polymesh-based design engine, which means you can reach higher polygon numbers with lower system requirements than similar applications. ShapeLab supports traditional professional design workflows and allows you to achieve more detailed objects than you would in many other VR 3D modeling tools. Additionally, you have many tools for more control over your model's topology. You can use dynamic topology made for real-time tessellation of the mesh based on the level of detail needed locally. You also have options for global mesh manipulation. Also, ShapeLab offers rapid VR sculpting and high performance with all the industry-grade tools that you will need, such as vortex painting, stamping, and Boolean operations, and most importantly, sculpting tools to enable you to make well-detailed 3D assets. And the good thing is, you can export your models to edit them in other 3D software or for 3D printing, as it supports multiple file formats like FBX, OBJ, STL, and GBL. As of recently, you can also generate and export PBR texture maps. One of the things that I like most about the software is the intuitive interface and the many options of materials and environments. Overall, ShapeLab is amazing, and it allows you to easily create organic shapes from simple forms to complex designs. It is unique among VR creative tools in having a polygon mesh-based engine instead of a vortex-based one, and it has a feature set that can provide users of different backgrounds with tools to create 3D assets effectively. So make sure to check out ShapeLab with the link in the description and let us know what you think. Now back to the video. First, for organic shapes, if you look at the nature around us, you'll notice that it exhibits a level of randomness and irregularity that can be challenging to replicate using the parametric modeling workflow. After all, it mostly relies on precision and numbers, whereas procedural modeling offers, for example, noise nodes. So to understand these better, imagine we have a flat plane, and we can use noise maps to generate natural environments. To make it simpler, noise maps are usually black and white images with random details that could be changed or animated. And when we apply them to our plane surface, the black parts will stay on the ground, whereas the white parts will rise as hills and mountains, for example. Meaning, if you want to create a natural terrain, you can use noise maps to create things such as valleys and cliffs, which is very hard to do using parametric modeling. The idea behind procedural modeling is having a bunch of nodes and then combining them in a way that you desire. The quality and quantity of these nodes can be different from one software to another. But when we look at Houdini, for example, a software that does it best, it offers a wide range of variations in textures, patterns, and mesh generation, which means that you have greater flexibility on the type of models that you can generate and their complexity, because you can add any number of nodes to your node tree. But this also means that parametric modeling is generally considered more accessible and user-friendly, because procedural modeling often includes a lot of nodes, which can be scary to a lot of people. Also, it might be tricky to learn how to interact with it, especially the likes of math nodes, whereas parametric modeling is more straightforward, at least in my opinion. Another fascinating fact about procedural modeling is that by adding and removing nodes within a node tree, it is easy to generate variations, which is perfect for large-scale environments. For example, if you're trying to make a gigantic apocalyptic city, it will be noticeable to the viewers if you're only using a few buildings, and manually modeling hundreds of buildings isn't that realistic and could even take months. So a more realistic approach is building them procedurally, where you can adjust the size and details of elements such as windows and doors, as well as textures, and even add other procedural details like ivy or wall cracks. And you can do this to enhance the overall aesthetics of the buildings. And these buildings can then be scattered across the city to be used in any of your projects. Now, if you want to know how practical each method of modeling will be, then procedural modeling and parametric modeling offer different approaches when it comes to efficiency and performance. So procedural modeling excels in its ability to quickly update designs thanks to its node-based system that allows for rapid modifications and adjustments. On the other hand, parametric modeling goes straightforward to the point when you want to edit a certain part of an object, whereas procedural modeling for specific adjustments can be tricky depending on what you want to do, and sometimes huge node setups might be needed, which can make it a bit difficult and slow your computer and rendering process. But an easier way to do that is by converting your procedural model into a regular 3D model that you could manually manipulate and optimize. I hope you guys found this video useful and informative, so if you did, please give it a thumbs up and take a look at some of our previous videos. Thank you guys very much for watching, and I will see you in the next one.